In the previous class, we have discussed that what are colligative properties, and also we discussed the first two colligative properties, that is relative lowering of the vapor pressure and the elevation in boiling point. Now, we will discuss the rest two properties, that is depression in the freezing point and osmosis. The depression in freezing point. Dear children, you must have studied that for clearing the snow in the cities where the temperature goes below 0 degrees Celsius, we sprinkle salt. It melts the snow and it becomes very easy to clear it. Also, we know that in the car radiators, we use water as a coolant. But the freezing point of the water is 0 degrees Celsius. Then what will happen if this vehicle is in the cities or in those countries where the temperature is below 0 degrees Celsius? It will freeze in the car radiator and it will not solve the purpose. So, what to do? What to do to avoid this situation? We add antifreeze. Antifreeze means the component, the substance which will prevent water from freezing. And we increase the amount of the antifreeze as the situation or the conditions require. This is all due to depression in freezing point. Now, let us discuss why there is a depression in the freezing point. That there is the lowering in the vapor pressure when we mix a non-volatile solute to a pure solvent. Freezing point also we know that it is a temperature at which a liquid changes into solid state. It is the temperature at which the vapor pressure of the pure liquid solvent is equals to the vapor pressure of the solid solvent. But when we mix something non-volatile into this to make a solution, there will be a lowering in the vapor pressure, and hence at some lower temperature the solution will freeze. And this is known as the depression in the freezing point. That is, the water will not freeze at 0 degrees Celsius. It will freeze at something, a temperature lower than that 0 degrees Celsius. And depending upon the situation, depending upon the circumstances, we can increase this amount of solute and the water will not freeze. So, we can say that the depression in the freezing point is depending upon the number of the solute particles. Therefore, it is a colligative property, because earlier we have defined the colligative properties are those properties which depend upon the number of the solute particles and not on their nature. Let me explain all this through a graph. Here, the graph is between temperature and vapor pressure. Temperature is along the x-axis and along the y-axis we have the vapor pressure. You can see the three curves. The curve AB is for the liquid solvent, curve BC is for the solid solvent, and curve ED is for the solution. Temperature T0 or T0 you can say, it is coinciding with point B, and the B is the freezing point of pure solvent. That is, it is the temperature at which for the first time the liquid changes into solid state. And below this temperature we have solid solvent, and above this point B, above this temperature we have only solvent in the liquid state. From here you can also understand the definition of the freezing point, that it is the temperature at which the vapor pressure of the solid solvent is equals to the vapor pressure of the liquid solvent. Now, for the vapor pressure curve of the solution, you can see that the solution is freezing at some temperature below this normal freezing point. T temperature is below T0. So, we can say that there is the depression in the freezing point. delta Tf, it is the value of the depression in the freezing point. The more you add the solute, the more the lowering of the vapor pressure and more will be the depression in the freezing point. Mathematically, delta T is equals to IKFM. Delta T is the depression in the freezing point, I is the Windhoff's factor, Kf, it is the molar depression freezing point constant, also known as cryoscopic constant. Unit is just similar to the ebullioscopic constant, that is Kelvin kgs per mole. Small m is molality. You already know molality. It is the number of the solute particles dissolved in 1 kg of solvent. These are some sample cryoscopic constants. For benzene, it is 5.12 Kelvin kgs per mole. For camphor, it is 40. For water, it is 1.86. Normally, these values are given in the numericals, but for the safer side, you must learn these values for the common solvents for the solving the numericals. Mathematically, now you can see delta Tf is equals to Kf into W2 into 1000 divided by M2 into W1. Here again you can see that delta Tf is inversely related to the molecular mass of solute. Using this formula, you can find out delta Tf, the molecular mass of solute, or any other expression depending upon the numerical. But again you have to keep in mind that the temperature, if given in degrees Celsius, you have to add 273 to it and convert it into Kelvin scale. The next colligative property is osmosis. The process of osmosis is very common in our everyday life. For example, we know that the roots are absorbing water and minerals from the soil. It is through this process, that is osmosis. When the mothers, they put pickle, mango pickle, they apply salt on the mango pieces, the raw mango pieces. And we see that the raw mango pieces, they dry up, they shrivel up, the water oozes out. It is again an example of osmosis. We soak raisins in the water and the raisins, they swell up. This is again osmosis. And in these all examples, there is one thing common. All these structures like the raw mango pieces or the raisins or the root and the root hairs, they are surrounded by a semi-permeable membrane, also known as selectively permeable membrane. First of all, before explaining osmosis, I have to explain what is semi-permeable membrane. It is a continuous membrane with very small pores, and these pores are so minute that they allow only water molecules or the solvent molecules to pass through it. It does not allow the solute particles to pass through it. The presence of the semi-permeable membrane is very important to define, to understand osmosis. Osmosis is defined as the movement of the solvent particles from the pure solvent side to the solution side, or the movement of the water molecules from the dilute solution to the concentrated solution through semi-permeable membrane. Dear children, we have to mention the semi-permeable membrane. If we will not mention this, then the process will be diffusion, and these two processes are entirely different. Semi-permeable membrane can be natural and semi-permeable membrane can be synthetic also. Like the pig bladder or the parchment, they are the natural semi-permeable membranes, and cellulose acetate is a synthetic semi-permeable membrane. In exams, they ask you this example, give an example of semi-permeable membrane, either synthetic or natural. So, you have to keep this also in your mind. Osmosis and osmotic pressure. Dear children, when the osmosis takes place, a pressure is developed and that pressure is known as osmotic pressure. Osmotic pressure is a colligative property, and now you can very well understand that why it is a colligative property, because it is depending upon the number of the solute particles and not on their nature. If we want to stop the process of osmosis, on the opposite side we have to apply some extra pressure. This extra pressure should be more than osmotic pressure. If it will be less than osmotic pressure, the process of osmosis will continue. If this external pressure will be equals to osmotic pressure, the process of osmosis will stop. And if this extra pressure, this external pressure is higher than the osmotic pressure, the reverse osmosis will take place. Reverse osmosis, nowadays a very common process taking place. There are countries where there is no drinking water, there is no potable water, they have only sea water, and the sea water has salts. They cannot consume that water for drinking purposes. So, reverse osmosis is the solution of the problem. What we do is, from the sea water, the pure water is squeezed out by the process of reverse osmosis. This is known as desalination. In schools also or in your homes also you have seen the RO plant. What is this RO? This is reverse osmosis. In the schools or in the home, when we get the underground water through submersible, the underground water has salts, and these salts are harmful for our body. They deposit around the joints. So what we do? To use this underground water, we use the RO plant. In this, we use artificial or the synthetic semi-permeable membrane, that is most commonly of cellulose acetate. From the picture you can see the osmosis. The solvent is moving from the pure solvent side to the solution side. Mathematically, the symbol we use for osmotic pressure is pi. Pi is equals to CRT. C is the concentration, R is the universal gas constant, and T is temperature. Pi is equals to W2 into R into T divided by M2 into V. We have studied all the 4 colligative properties, and from the mathematical relationships, now we know that every colligative property is inversely related to molecular mass of the solute. I hope everything is clear to you.